Okay, on to question number 2 on paper 2. So we're given a pretty straightforward first part. It says a circle has a centre of 7 minus 8 and passes through the point P 2 minus 2. So here's a kind of a slight sketch of what we're looking at here. So we know the centre is down here at 7 minus 8, and we know this point P lies on the circle. We need to find the equation in the first part. Now whenever you're asked for the equation of a circle, however you need to get to it, there are two key things we need. We need a centre and we need a radius. Now this is constant, we're always looking for these things. So yeah, we're definitely given the centre straight away here, but we do not have the radius. But since we know P is actually on the circle, well, we know the distance between C and P is going to be our radius. So we're essentially going to try and fill in this formula. This is one of two formulas, and when given the centre and the radius, this is your go-to circle equation formula given in your logbook, where your centre is h and k and your radius is r. So let's try and find r by getting the distance between these 2 points. Now let's remember the distance formula, which also we have in our logbook, is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so let's look at the 2 points we have, and let's go 7 and minus 8 and 2 and minus 2. So let's label those our x1 and our y1 and our x2 and our y2. Let's put them in here. That means it's the square root of x2, which is 2, minus x1, which is 7, squared, of course, y2, which is minus 2 minus y1. So the minus by a minus, so using brackets is going to help us here. Also to be squared. So what's that going to give us? Well, it's going to be the square root of 2 minus 7, that's minus 5 squared. Minus 2 now plus 8, so that's going to be a plus 6 to be squared. So minus 5 squared is 25, and 6 squared is 36. So that turns out to be square root of 61. So we know the difference here. The distance between C and P is root 61. So we need to fill in this now. So all we're looking for is our centre, which we know to be C. So our centre is 7 minus 8. And now, of course, for this formula, this is our H and our K. And now we know our radius, which is, of course, root 61. So filling in this formula here, we have x minus h, which is minus 7, to be squared, plus y minus k, which is minus 8, and that's to be squared, equals to r squared, which is root 61 to be squared. And of course that simplified is going to be x minus 7 to be squared, can't do anything with that, plus y minus 8, that's y plus 8 to be squared. And of course when we square something that's square rooted, they cancel each other out, just leaving us with a 61. So that's the answer to the first part. So the next question says Q is a point on the circle that is closest to the x-axis. Find Q in third form. That just means you'll have square roots in your answer. Let's look at Q here. So if we look at the centre of the circle here, we know that above the centre up here there's some point Q close to the x-axis. We also know the radius of the circle is square root of 61. But we know the centre lies 8 units below the x-axis. Now maybe you know that the square root of 61 is a number a little bit less than 8. So if we look at this dot here, yeah, it's directly above, it doesn't quite reach the x-axis. So we know that this distance here is a radius. But what's this little distance in here? So if you like, have it drawn here, this little distance in here. Well, how do we get that? Well, we know from the dot, the centre to the x-axis is 8. And we know this is root 61. So this little distance here where I have a question mark is actually 8 minus root 61. So the actual distance in here is 8 minus root 61. Okay? And we actually know, since this point is directly above the centre, we know its x-coordinate is going to be 7. But what about this actual y-coordinate here? We know we come down a distance of 8 minus root 61 for this y-coordinate. So if we come down a distance to that, like if we came down a distance of 8, we have to call it minus 8. We're coming down a distance of minus this stuff here. So actually that gives us a point for Q of 7 minus this distance, which gives us minus 8, and then of course a plus root 61 because it's minus all this stuff. And that's actually that question answered. It kind of implies a small bit of common sense here, and you have to really understand the drawing, but it's definitely maybe a little bit trickier, a little bit outside the box thinking, but things like knowing the distance from a point to a line, which is the x-axis here, is a perpendicular distance or straight up, might help you. Now in question 2 part B, it gives you quite a bit, and it gives you a diagram as well. Now my red lines are my construction lines, but everything you see in black is kind of given to you on the diagram. So it says the point R is also on the circle, and it says the length of the chord P to R is 10 units. And the diagram shows two possible positions of R, and let's call them R1 and R2. And it says find the possible equations of PR. So you have a chord that goes from the point P, which we know about, to R, and of course the point P to another R, and both of these chords would have a length of 10. But let's find the two possible equations for it. So I've drawn this triangle in here, and this for the solution. And why have I done that? Well, if we look at this triangle from P to R1 to C, we know that that triangle, the length from C to R1 is going to be a radius, and the length from C to P is going to be a radius. Now let's not forget, I probably should have wrote that in, that the point P is 2 minus 2, just for future reference. So if I look at this here, what I'm going to do is draw the triangle. What type of triangle is that? Well, that's an isosceles triangle. If you draw a perpendicular line, or drop the perpendicular line down from the top, let's say the top of an isosceles triangle where you see the two side lengths the same, if this was the base, well, that will actually hit the middle of that baseline. Now the thing is, that baseline is one of the chords they're talking about, which has a length of 10. So I actually know from looking at this that this distance from P to O, I called it here, is going to be 5, and O to the point R is also going to be 5. Now look at these two right angle triangles. I can now get the distance from C to O by just using Pythagoras' theorem. So that would say that we have the hypotenuse of root 61, which is root 61 squared, should be equal to this distance, which we don't know, let's call it x for the time being, x squared plus 5 squared, and of course root 61 is squared, is going to be 61, x squared now plus 25, and of course that tells us that x squared is equal to 61 minus that 25, which is going to be 36, so therefore x should be equal to 6. So actually have this little distance in here of 6. Now why do we want that? Well, we're looking for the equations from P to R1 or P to R2. What's the equation of a line formula? Well, let's not forget that y minus y1 is equal to m times x minus x1. So what do we need to satisfy this equation of a line formula? We need a point. Because we do have a point on the chords, we know the point P, so we actually have the point of 2 minus 2. What do we not have? The slope. And of course two slopes exist here. We either have this slope or this slope. So let's just call the slope m for the time being. So that means that our actual equation is going to have y minus, and I like to label these points, y minus y1, that's minus a minus 2, is equal to m times x minus x1, which is x minus a2. So that's going to be a y plus 2 is equal to mx minus 2m. And when we say we'll bring that all to one side, as in the ax plus by plus c, we'll bring that all to one side, we get an mx over here, and then, sorry, I'll bring this stuff over here, so mx, and now we'll write y next, that's going to be minus y, and that's going to be minus 2m is still there, and of course that's a minus 2 that comes over to meet that. And let's make all that equal to 0. So literally I brought this part over here and wrote it out like this, so I have it in that format. Now when we have this line equation format, there's actually the reason for doing this, and this is the hardest part, I think it's definitely one of the trickier questions I've seen on the paper. We actually can tell something else. Because of this isosceles triangle property, and we know a line drop down from here is going to bisect that perpendicularly, there is another formula. A formula that's not used that often, but the perpendicular distance from a point to a line, or the closest distance from a point to a line, is perpendicular. So there's this formula that you have in your book for perpendicular distance of a point to a line. And the perpendicular distance of a point to a line formula is one of the last formulas in the coordinate geometry section, is this. It's ax1 plus by1 plus c all over square root of a squared plus b squared. So that's where you have some coefficients, a, b, and c in your line equation. If you write your line equation as your ax plus by plus c is equal to 0, and you also have some point x1, y1. But we actually do have this information for this here, because we know that this point c is 7 minus 8, and we already know the answer. We know the distance from c to this line PR, and it's the same for this one here, is actually 6. Why is it the same for that one? Because that's also a root 61 there. So let's just concentrate on one, and we'll get her. Should have 2 answers for this, and you'll see as it progresses how it works. But definitely a hard question. So what are our coefficients we're working with? Well, we know our point x1, y1 is the point c, 7 and minus 8. So that's going to be our x1, and that's going to be our y1. So what about our A, B, and C? Well, we're looking for the perpendicular distance from this point to this line. And we made a line here with m's in it that we don't know about, but we can use the m's and see if we can solve for this m. So our coefficient A is with x. So for us, our A is going to be m. Our coefficient B is with y, so B is going to be a minus 1. And our coefficient C is going to be the constant, the last part there. So what's our constant B? That's a minus 2m and a minus 2. So we actually have all this info. So let's put that into this equation here. Knowing the answer, remember, we figured out in Texas theorem, is 6. So let's say 6 equals to, so absolute value bracket. So what's our A? And our A is going to be an m. So we have m times x1, which is 7 for us, plus b, what's our b? That's a minus 1, times our y1, which is going to be a minus 8 for us, and then plus our c, which is this stuff here, minus 2m and a minus 2, all over the square root of a squared plus b squared. So a is m, don't forget, and our b squared is minus 1 squared, so that's a plus minus 1 squared. So now I have this. I have 6 equals to, and inside in our absolute value brackets, let's start working on some of that. So we have 7m, minus 1 by minus 8, that's a plus 8, plus 8. Then we have a minus 2m and a minus 2, all over what looks to be a square root of m squared minus 1 squared is regular 1, so that's just a plus 1. So we have all this stuff here. So a small bit of tidying up here will give us 6 times this stuff here. We're going to try and make it all in the one line. M squared plus 1. So I just brought this up over here. Equals to, inside the absolute value brackets, we have a 7m minus a 2m. That's going to be a 5m. And we have an 8 minus 2. That's going to be a plus 6. So we're down to here so far, and as this problem is so long, I have to go to another sheet now. So let me write it at the top of this. So I have 6, and then that's times the square root of m squared plus 1, and then equals to absolute value. I had 5m and I had a plus 6. So it's important we don't just ignore those absolute value brackets. What are we going to do next to get rid of those? Well, it kind of ties in with what we have to do on that left side to solve this for m. And remember, we can solve this for m now. We just want one variable and we have an equation. So let's square both sides. Now these are two factors, so it's equivalent to squaring like x times y. You could square all that and you get x squared, y squared, don't forget. Okay, so squaring this is going to be squaring the 6 first, that's 36, and of course squaring the stuff under square root just gets rid of that square root bracket. So we have 36 times m squared plus 1. Now by squaring the right hand side, you're actually squaring a modulus bracket, and remember it can be both negative or positive in there, but by squaring it you're only dealing with the positive, so actually that kind of gets rid of your problem of these modulus brackets here. So squaring this is just like squaring regular brackets now, except we can disregard these modulus brackets because of course once we square something we're always dealing with the positive. So square the first part, that's going to be 25 m squared, and then you square the second part, which is 36, and then multiply the two of them and double it, and that's going to give us what, 630m, 60m. That's my way of squaring in my head, but you of course can just do this if you want. So essentially that's what I've just done here to get to here. I've squared the right hand side, I've squared the left hand side. So let's multiply that in. That's 36 m squared plus 36, and we have a 25 m squared now plus 36 over here plus a 60m. So these 36's are going to cancel with each other, and now I have 36 m squared, and I bring this over, minus 25 m squared is going to give me 11 m squared over here, and then that comes over as a minus 60m. I bring it all to the one side because this now is a quadratic equation in m, and the only way we know how to solve quadratic equations is by bringing them to one side and set them equal to 0. So here we have no constant term, so they're actually pretty easy to factorize. Just factor out the variable, which is m in this case. So if we're taking m outside, that's m times 11m minus 60 equals to 0. And of course that means m is either equal to 0 or 11m minus 60 is equal to 0. And this gives us 11m is equal to 60. We bring over to 60, or m is equal to 60 over 11. So actually I have two values for m, and we know m is a slope. So actually if you look at our diagram here, we can see we either have a slope of 0 or we either have a slope of 60 over 11. So that's like 5 and a bit, 5 and a 5, yeah, and just over 5 of a slope. So you can see that our slope is 0. Well, this looks like this line is horizontal then, and we can see that the other slope is very positive, which is this one here, because it's 5 and a bit. So this is a very positive slope. And remember that we actually wrote out our line equation. It should look something like this here, we said earlier, if we just take m to be some slope. And this was our line equation just in m when we didn't know the slope, but we needed this line equation to use the perpendicular distance formula. So let's just simply replace these m's by the values for m that we got. So I'll write it down again. So I had mx minus y minus 2m minus 2 equals to 0. So if m is 0, the first part goes, that's m times 0, which is gone, minus y minus 2 times 0, which is gone, minus 2 equals to 0. And that of course leaves me with minus y minus 2 is equal to 0. Minus y then is equal to 2, or then y is equal to minus 2. And of course that does look like the line that's just below the x-axis, where this is minus 2, and of course if it's horizontal across from P, that makes sense because that had a y coordinate of minus 2. So simply the line coordinate of y is equal to minus 2 is a horizontal line through the y point minus 2. And the other option I had for a slope was this one here. So that means then I replace all these m's by 60 over 11, so that gives me 60 over 11 times x, and then minus a y minus a 2 times 60 over 11 minus 2, and that was all equal to 0. So that gives me 60x over 11 minus y minus 120 over 11 minus 2 equals to 0. And of course when we do out and we change out all that, we might have to multiply everything across by 11 to make this a little bit easier to deal with. That gives me 60x minus 11y minus 120, and then minus 11 times that is 22 equals to 0. And I might just bring this all to one side. So I'll write the x term first, which is 60x, and then I'll write this just as minus 11y. Minus 20 and a minus 120 and a minus 22 gives me minus 142. And I don't think they ask in this question to give your answer in a particular format, so I mean, that's in the format ax plus by plus c is equal to 0, so I'm happy enough with that. But it certainly was a long question and very tricky, so maybe go back over that if you have time and see do you fully understand it.